Welcome to this lesson on set theory. In this lesson, we take a deep look into the concept of set, its theory, then set operation, and also how you deal with Venn diagrams. So I will introduce you to set theory, then my colleague will continue from there to take you through the journey of set. Now, by definition, let's first look at definition of set. So a set is a collection of objects with unique characteristics. So when you have a group of objects or a collection of objects that are unique in nature, then it becomes a set. Unique characteristics means no two members of the same set will have the same characteristics. So, for example, you might have a set of telecoms operation in Nigeria, telecoms operators in Nigeria. Now, this is a group, is a collection of objects, telecoms operator, but it's unique because we're only dealing with telecoms operators. So it has something that defines the characteristics of the set itself. So let's quickly look at our set denotion. How do you denote a set? So first, you have the object of the set, which is denoted by a capital letter. Set object is denoted by a capital letter or an uppercase letter, as the case may be, capital or uppercase letter. Then we have the set characteristics, which is denoted by, it starts by the opening brace and it ends by a closing brace. Then we have the set members. Members of a set are usually listed within the characteristics. So between the opening and the closing brace, you list the members of the set, and they are usually comma separated, which means you separate them with a comma. So one of the first characteristics of the members is they are comma separated. Another characteristic of members of the set is they are not repetitive. So they are not repetitive, which implies that you can't have the same member listed twice. So in the example I gave, where I was looking at the set of telecoms operation in Nigeria, so let's denote that with a set. Let's say we want to represent the set of all telcos. Telcos mean telecom operators. All telcos operators in Nigeria. Okay, so what we do is we take a representation which will be the object of the set. So we can say we want to represent the set with T. So this is the object, is equal to, then we open the characteristics, then we list our members. So telcos operation in Nigeria, we have MTN, Airtel, we have Glo, we have 9 Mobile, then we have other ones like Eastream Networks. Then you close the curly brace. So this is how a set is represented. You can see that none of the members of the groups are repetitive. I did not repeat any one of them twice. So that's one way of representing a set. Another way of representing a set is this. I might represent the same set like this. And I say this. Operators in Nigeria. So this means the set of T, where T, this means where. So this is the set of T, the object, where T is telecoms operators in Nigeria. So it means that if I have something like this, this means a set of N, where N, so this is set B that has membership that is less than or equal to 10. So it means that set B, where B has a member that is less than or equal to 10. So we represent this as B is equal, so numbers 1 to 10, less than or equal to 10, that means 10 inclusive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, that is what a set is all about, and this is how you represent a set. So every other thing regarding set, the definition of set, the operations of set, and also representing of set with Venn diagrams, my colleague will take over from here and will take you through the class. So all you need to do is to type the link you can see on your video now, on your screen now. Type the link on your browser. Open your browser, Google Chrome, Mozilla Firefox, or Opera Mini, whichever browser you are using, and type this link in the browser one by one. Pay special attention to the capital letters, where you have the capital letters and where you have the small letters. Then you'll be able to continue the class. Thank you.
Let's look at these some definitions before we move to operation of a set. When we say cardinality of a set, the cardinality of a set is the number of elements in a set. Simple representation is just number of elements in the set, and is denoted by NA. That is if our set, for example, if set A is equals to, let's say, 2, 3, 5, 7, we say cardinality of A is equals to, you count the number of elements in that set, 1, 2, 3, 4. We say cardinality of A is equals to 4. So if you see a set without an element has a cardinal number of 0, we say a set without an element, we say cardinality of that set will be equals to 0. Likewise, a set. So likewise, if you say a set with only one element, this is in quotes, only one element, we say cardinality of that set, let's say NA, will be equals to 1. That set can also be referred to as a unit set, or we say from the word single, we said singleton set. So the next one is equal set. Equal set is denoted by this. So we say two sets are equal if they contain the same element, if they contain the same element. For example, let's say our A is equals to 2, 4, 6, 8, and we say our B is also 2, 4, 6, 8. We generalize and say A is equals to B because they have the same element. You can see 2, 4, 6, 8 and 2, 4, 6, 8. So A is equals to B. Another one is empty set. There's a mistake students make in this empty set. A set that contains, as it appears, empty. Empty is if you are having nothing in that particular thing. So a set that contains no elements. A set that contains no elements is what is called empty set. So you can just represent A as you open the bracket and close the bracket. Nothing is there. Or you write it as file. This is a symbol that we call file. So you either write it as just a bracket with nothing inside and a bracket and a symbol like this. But I see some students making some mistake. If you have A to be equals to 0,